Hello! In this video, we are going to prove the following theorem. Suppose f is a function from a to b, and g is a function from a to b. Then, for every element x in a, f of x equals g of x. If and only if f is equal to g. Okay, so to prove this, let's suppose that we've already declared a function f from a to b and a function g from a to b. And so our whole goal now is to prove this statement. And really, we're trying to prove a statement containing if and only if. So what we can do is we can prove that if this is true, then this is true. And if this is true, then this is true. Let's start out by proving if this is true, then this is true. And to do so, assume this is true. And our whole goal now is to deduce that f is equal to g. So really, we're trying to prove that two sets are equal. So what we can do is we can prove that everything in this set is also in this set, and everything in this set is also in this set. Let's start by proving that everything in this set is also in this set. And to do that, give me an arbitrary element of f. I'll call it a comma b. Now, because f is a function from a to b, we know that this means a is an element of a and b is an element of b. And I'm actually just going to write that a is an element of a. Also, because f is a function, we know that this is equivalent to saying that b equals f of a. Now, because a is an element of a, and this statement is true for every element in a, it must be true for a. So we can take x and substitute for a, and we go get that f of a equals g of a. Now, because b equals f of a and f of a equals g of a, this means b equals g of a. But we know that this is equivalent to saying that a comma b is an element of g. So notice, we started with an arbitrary element in f, and we deduced that that same element is also in g. Since a comma b was arbitrary, that means everything in f is also in g. So now that we've shown everything in this set is also in this set, now we're going to show that everything in this set is also in this set. To do that, give me an arbitrary element of g. I'll call it p comma q. And we're actually going to get pretty much the same argument that we did above, right? To start, because g is a function from a to b, we know that this means p is an element of a and q is an element of b. And I'm just going to write that p is an element of a. Also, because g is a function, we know that this is equivalent to saying that q equals g of p. Now, because p is an element of a, and this statement is true for every element in a, it must be true for p. So we have that f of p is equal to g of p. So now, because q equals g of p and g of p equals f of p, that means q equals f of p. But we know that this is equivalent to saying that p comma q is an element of f. So notice, we started with an arbitrary element of g, and we showed that same element is also in f. Therefore, everything in g is also in f. So at this point, we have shown that everything in f is also in g, everything in g is also in f. This amounts to proving that the two sets are equal. And so now, we have proven if this is true, then this is true. Now we're going to prove if this is true, then this is true. And to do so, assume this is true. Our whole goal now is to deduce that this is true. So we're trying to prove a statement about every element in A. So give me an arbitrary element in A. I'll call it x. And we want to show that with this arbitrary element x, we have that f of x equals g of x. To start, because x is an element of A, and f is a function from A to B, we know that f has a functional value at x. We could say, for instance, let y equal f of x. But we know that this is equivalent to saying that x comma y is an element of f. But because f is equal to g, this means that f and g have the same exact elements in them. So because x comma y is an element of f, this means x comma y is an element of g. And next, since g is a function, we know that this is equivalent to saying that y equals g of x. So notice we have that y equals f of x and y equals g of x. Since both f of x and g of x are equal to the same thing, they must be equal to each other. So, we started with an arbitrary element x in A, and we deduced that f of x equals g of x. Since x is arbitrary, this means for every element x in A, f of x equals g of x. So we have proven precisely this statement. So we have proven if this is true, then this is true. And so at this point, we have proven both parts of the if and only if, which means we've proven the theorem. And yeah, that is pretty much the idea of how you could prove a theorem like this. And yeah, that's pretty much it for this video.